Greetings. Today in this video, I'll be giving you a walkthrough of the AP Calculus AB Free Response Question 2. This is a continuation of my series on the AP Calculus BC and AB Free Response questions. So number 2 is a question about particular motion, and a particle moves along the x-axis so that its velocity at time t greater than 0 is given by v of t equals that function. So there was one time for A, there was one time t equals tr on the interval where 0 less than t less than 2, where the particle is at rest. Find t sub r, and for 0 less than t sub r is the particle moving to the right or the left. Okay, so for the particle being at rest, v of t needs to be 0. All right, so I have v of t stored in the y1 function, and I've set the window to be between 0 and 2, since this is the range of time that we're examining. And when I graph v of t, I can see that it hits the x-axis at this point, meaning that it's 0. So to calculate that, I'm going to do second calc 0 and find that 0, and that is 1.426. All right, so that's the answer to the first part of question A. The second question asks, is the particle moving to the right or the left? As we can see, from 0 going all the way until tr, we can see that the velocity is positive because it's above the x-axis. Therefore, the particle is moving to the right. And that's question A. So question B asks, find the acceleration of the particle at time t equals 1.5. That's the first part. So remember that the acceleration is the derivative of velocity. And so to find the acceleration at time t equals 1.5, we're going to find the derivative of velocity at time t equals 1.5. To do that, I already have velocity stored as y1 in my calculator, so I'm simply going to do the derivative function of y1 at x equals 1.5. And that is negative 0.999, and rounding, we get negative 1.000. They do not give us units in the problem, so we can't really include any units. So now it asks, is the speed of the particle increasing or decreasing at time t equals 1.5? So the speed is increasing when velocity and acceleration have the same sign. We can see that velocity is negative. Let's quickly check and see if we can see that acceleration is negative. Let's quickly check and see if velocity is negative. I'm going to do y1, 1.5. This is v of 1.5, and that's negative 0.077. So I'm going to say that v of 1.5 equals negative 0.077. So then I'm going to say that the speed is increasing because v of 1.5 is less than 0 and a of 1.5 is less than 0. So speed is increasing when velocity and acceleration have the same sign, and it's decreasing when they have opposite signs. Question C asks, the position of the particle at time t is x of t. and its position at time t equals 1 is x of 1 equals -3. Find the position of the particle at time t equals 4. Show the setup for your calculations. Okay, so we know x of 1, and we know v of t. So using that initial condition, we can find x of 4, the position of the particle at time t equals 4. And that's equal to this initial condition plus the definite integral from 1 to 4 of v of t dt, because the velocity is the derivative of the position. And I'm able to do this by the fundamental theorem of calculus. So what I'm going to do is I'm just going to go over here to my calculator, and we are just doing -3 plus the definite integral from 1 to 4 of v of t, which I have stored as y1 dt, and that's -2.803. And that's it for question C. Question D. Find the total distance traveled by the particle over the interval t between 1 and 4 inclusive. Show the setup for your calculations. Okay, so remember that distance is the integral of the absolute value of velocity. So, the distance in this case is going to be the definite integral from 1 to 4 of absolute value of v of t dt. So, doing this on the calculator, definite integral from 1 to 4 of absolute value of v of t, which I have stored as y1 dt. And that total distance is 0.958. So that's it for this question. Thanks so much for watching. I hope you found this video helpful, and if you did, I would really appreciate if you could like and subscribe. See y'all in the next video.